let's move to the next speaker, which is Mrs. Francesca Ferrazza. Francesca is head of Magnetic Fusion Initiative in ENI. It's in charge of supporting the development of fusion technology and project. She has also a background in semiconductor physics and has over 30 years of experience in applied research in R&D management. She is also a member of many national and international scientific committee and working group, and also has published on many journals and conference articles and papers, book, chapter, and is co-inventor of patents in the field of photovoltaics. Now, Francesca, the floor is yours. And let's start with your presentation, please.
Thank you very much for the kind introduction. I'll just share the presentation. Can you see it?
Not yet.
Can you see it now?
Not yet.
Oh. Well, to my knowledge, it should be in
Yeah.
Is it okay now?
Yeah, it's okay.
Okay. Thank you very much. Okay, so is it in presentation mode now? Okay, so good afternoon, everyone, and thank you for the invitation. I'll talk about our activities on fusion energy, on the development of fusion energy. As a company, we have a strong decarbonization strategy, and it resonates a lot with what was told by the previous speaker. We have a commitment to decarbonizing our portfolio by 2050 with a sustainable mix of energy. We are committed to renewables, to biomass, to biofuels, to hydrogen, to CCS, and to circular economy, and this is happening now as part of our strategy. But then for a longer term, medium to long term strategy, we are also committed to fusion, to magnetic confinement fusion, as a source of energy which is breakthrough and in a path that manages the technical risks through validation of innovative technologies. The aim is to realize a compact fusion energy power plant which is commercially exploitable in a reasonably short time frame, less than 15 years. And this is an acceleration compared to what is traditionally proposed for fusion. We really think it's a breakthrough technology, and we have committed to demonstrate that net energy can be produced in the mid of this decade, so by 2025, and that it's possible to realize a first working power plant by the early 2030s. And this is through the investment with our venture capital partner, NENext, in a spin-out of MIT, building on known scientific principles, so known science from previous experience, especially at MIT with the experience on ALCAT or CMOD, and innovative technology. The innovative technology is based on a new class of superconductors which can reach high fields. And this means that it's possible to compact the design of the reactor and make a modular and fairly small kind of power plant. Now, the investment for us is strategic, and it's not only financial. So we are developing skills, technology, and supply chains for magnetic fusion in an active way. So we have a unit, a dedicated unit, which has engineers and looks also to innovation and R&D and project management. And we are involved and contributing to some of the development of the spin-out in which we invested, which is called Commonwealth Fusion Systems, CFS, and which foresees, as I said, two main steps: the demonstration of net energy by the 2025 and the power plant by the early 2030s. But apart from this, we have also invested in a joint venture with Enea to build an experimental plant called DTT, diverter tokamak test, which has the main objective of studying the diverter, so the heat part of the system. What is important is the timeline that we propose and which we have as target in terms of technologies, of the plant, of the power generation that we want to demonstrate with fusion. We know it's complex, we know it's complicated, and we have a path which goes through technology development with academy here in Italy and in the US. In Italy, there's a strong technological and scientific community in fusion, and so we're doing basic research and advanced modeling with the National Research Council and with MIT, with the aim of course, finding solutions, accelerating innovative technologies, and also developing competences, because skills and people are obviously key to the one of the key factors of the success of the sector and of the technology. The work we're doing with Enea is an engineering project in order to develop the skills and understand the key factors in terms of HSE, for instance, what is needed for a plant. And this is what we are doing with Enea in Frascati, near Rome. And it's de-risking and a sort of engineering kind of approach to get to the right skills and the right timeline for development. The industrial pilot plant itself will have to demonstrate net and positive energy, as I said, and at the first industrial part. And the timeline we have is fairly short. Now, the first milestone was the development and the testing and demonstration that the new superconductors could be fit into a magnet, demonstrating the high field, 20 Tesla. And this was done in September 2021, validating the approach of a compact reactor chamber. So the demonstration plant, which I've mentioned, is under construction in the US. And as a company, we are contributing to its development. In the meanwhile, we are working here in Italy, but also in the US for the main goals of demonstrating a high field, compact, continuous and profitable production of clean energy. Now we know there are many unknowns. At least we know which they are. So if you ask me, what do I think of fusion being a game changer for solving the net zero equation? Well, I say yes. It can be a game changer. There's still quite a bit to do, and this does not contradict renewables or other forms of energy, because we need all of the above for the net zero equation. And with this, I thank you very much for your attention.